Okay, here we go, Chapter 2. We're going to start looking at the basic system. Okay, here are the objectives. Pretty self-explanatory. Functions of fluid power, the basic structure, and the basic component or groups involved in structural fluid power systems. A few more, the functions of the components, and we'll get into some detail on that. Similarities and difference between hydraulic and pneumatic, and the operation of how these things work. Now, fluid power systems are very specific on what they do, so each one is unique. You might get something like a power unit, which is a general, provides flow, but what it does with that flow has to be hooked to some more components, right? And as you add them together, right, they perform the desired work. This is a system. Now there are 5 functions that it has to happen. One is conserving energy. And it does this. There's different ways of looking at that. Basically, the way you can tell if you're not conserving energy is if it's not doing work, it's making heat. So if you got a hot system, oh man, you got some problems with your energy being wasted. And how it flows through the system, the distribution of that system. And again, it starts off with a pump and moves out from there. And how you control it. We're going to talk about directional control valves, different types of valves. What kind of performance you're going to do, work performance. We're looking at actuators here and fluid maintenance. Almost 80% of all failures are because of contaminated fluid. So you take the 5 things we just talked about and you try to integrate them. When I was a hydraulic engineer, we look at this and we just made the valve part, but we were very much in touch with the other components. So it's all got to work together. So what do we have to do? We can look at different components, right? And each one has their place in the system. The power unit group. This is the one that consists of the prime mover, which would be a motor, and the pump. It creates the flow. Actuator group. This is the one that actually does the work that you want and the way you want it. This could be a cylinder. If you're talking about mobile system, it could be the thing that picks the hitch up and down. Pumps the combine when it's moving. The conductors group, that's the tubes and the different hoses that connect everything together. Control valves, these are like the little brains. These are the things that control where the fluid goes and how much and all that. And finally, the maintenance group. This is a filter. A lot of times you might have a radiator to cool it off, but this is the thing that keeps your fluid in good shape. Again, the power unit group has got the prime mover. This is the thing that electric motor or gas motor, one that actually turns the pump. And the pump itself is the one thing that basically is the one that pushes the fluid. And notice I said pushes the fluid into the system. If you're talking about pneumatics, you're talking about the compressor, right? And then you got the reservoir. This is stores the extra fluid. We'll talk about that a little bit later. Receiver in pneumatics. Yeah, that's the tank that holds the pressurized air. Now the actuator group, this is the one that performs the work. In this case, you're looking at a picture of a cylinder that's pushing back and forth. A motor will be something that turns. You can see like a big earth mover. A lot of times they have the hydraulic motors in them that make them turn. But basically, this is the part that turns the hydraulic pressure and flow into mechanical work. Now the conductors, this distributes it throughout the system. Again, you got the pipes, tubes, and hoses. There's a lot more to this than you would think. If it's too small, you're going to starve the system. Got too many kinks in it, you're going to get bubbles. You're going to get noises. This is an important part of it. We'll talk about that a little bit later. Control valves. These are the things that control the fluid pressure, flow direction, flow rate. You got the directional control valves, pressure control valves, and flow control valves. So where the flow goes, how much pressure it has, and also how much flow goes that way. And we're going to do a lab, and you'll see what we're talking about with this. Okay, fluid maintenance group. We're talking about the filter. It's like an oil filter on the car. There's an old question: does a dirty filter work better than a clean filter? The thought being that a dirty filter, since it's more clogged, it basically has to keep the smaller and smaller particles out. So is a dirty filter better than a clean filter? But filters are the ones that keep the dirt, moisture, and excessive heat. Again, I'm talking about the radiators. Now there's some few differences between the hydraulic and pneumatic systems. Basically because pneumatics it's a compressible fluid, right? So it's got to change a little bit, but the very little bit too in the terminology. But basically a fluid doing work, whether it's liquid or gas, it's the same fundamentals. We're going to focus primarily on the hydraulic bit. Now the power unit, this again in the prime mover, it's the electric motor or the gas engine or diesel engine that are the prime movers, and they turn the pump. Now the pump produces flow, not pressure, it produces flow. The flow inside the pump is actually created by squeezing the fluid. All right, so the fluid gets pushed into a void and gets squeezed out another direction. That's how flow is created. And we'll have some in the lab. I'll show you what we're talking about. And if you think of flow, it's energy. Pressure and flow, multiply them together, you get energy. So think of this as moving energy. Okay, you tack a big tank to store the extra oil not being used in the system. You got a reservoir, and put that on your pump. Combine it with your pump, you got a power unit. Okay, a couple things the reservoir does, since it's just sitting there, it also cools it, and also allows dirt to settle out of the oil. So it cleans and cools it at the same time. Again, the actuators are the bits that turn the hydraulic energy into mechanical energy or mechanical work. If you look at the picture, we got a hydraulic cylinder. It's actually used to turn the wheel of this tractor. Cylinders produce linear motion. Motors produce rotary motion. And here you go. You see the motor, right? This thing's just spinning, right, on some kind of winch. They produce rotary motion. When you have pressure, these things want to go from high pressure to low pressure. So that's what gives the actuator its motion. The speed of that actuator depends on how much is flowing. So the flow controls the speed. Pressure controls how much work you can actually get out of it. Okay, here you see a cylinder, right? You got two ports, and we're going to talk about valves later on, so we control the pressure and the outlet on those ports. We can switch them around. So basically what we'll do is we'll push that cylinder back and forth, make sure it's sealed off good. And so you got the body, the piston rod, and the piston itself, and this thing will just go back and forth depending on how we apply the fluid flow and pressure through the ports. So conductors, this is the stuff that transmits the fluid to the different components, pipes, tubes, hoses, and you'll see some of those in the lab. You also got some examples in the book. Control valves. First one we're going to talk about is directional control valve. This actually controls the direction of the movement in the cylinders and the motors. Remember that picture of the cylinder? We can use a control valve to apply high pressure on one port, low pressure on the other, or we can switch it around using a directional control valve. High pressure on the other port, low pressure on the different port. It changes the path from to and from the actuators. Okay, pressure control valves. You know, if you get too much pressure, in theory, if you have infinite amount of resistance, you can go up to infinite amount of pressure. But I wouldn't want to be around it, okay, because this thing's going to blow. So pressure control valves, they relieve the pressure, so it doesn't overload on pressure. And restricts flow to part of the system, kinda, but it does basically just relieves the pressure. Allow fluid to return low pressure to area. So what you got is high pressure. This thing will pop open at a pre-designated pressure and dump it off into tank or low pressure. If this thing looks kind of like a water spigot, it's because it's like a water spigot. What you're doing is you're controlling the flow. In this case, the amount of flow. The bigger the opening, the more you get, right? So it is a function of the area that this thing's flowing through. Okay, fluid maintenance devices, filters, that obviously it filters out the dirt and contaminants. Separators, it keeps different types of oils separate, not different types, basically dirty oils away from the clean oil. And I'll show you an example in the lab. Lubricators, yeah, this is one that keeps everything greased and running well. Very important, very important. Again, 80% of all failures are a result of fluid maintenance being not up to snuff. I don't like this slide so much, but we'll talk about it. Of course, the pump originates the oil for hydraulics. Low pressure is on the inlet side. It's basically a tank. And what happens then, skip that pass through a filter. It doesn't have to pass through a filter. In fact, we'll talk about why you probably don't want a filter on the inlet side. But anyway, it comes into the pump. Inside the pump, right, it's got basically a low pressure system that draws lets the atmosphere push the oil into the pump, and then it squeezes it out. That's what creates flow. And that flow and the corresponding pressure gets directed by the directional control valve to where you want it. And then that flow and pressure results in work by the actuator, the cylinder, the motor. The pressure control valves limit the pressure, right? That's one way of controlling it. You do need some pressure, but you don't want excessive pressure. Flow control, speed is a function of flow. So as you control the flow, you control the speed of the actuator. And then you want to return that oil somewhere. You got to have some kind of return system. In a pneumatic system, instead of a pump, you got a compressor, and that creates basically pressure, and that flow is then it results in flow, and then it goes over to the actuator. It's got to be filtered also. You'd be surprised how much water there is in the atmosphere, and you can store it in a big tank, and basically after you use it, usually it just gets split off into the atmosphere. 6% of all the energy in Arkansas is used to compress air. There's a statistic for you. Pneumatic systems, at the workstation, you got the pressure regulators. That's the working pressure. You got to have a filter and also a lubricator. In hydraulics, it's basically internally lubricated. Hydraulic oil is a good lubricator. That doesn't happen with pneumatics. You might want to add lubrication in the air somehow. And then you move it through the directional control valve. It goes to the actuator. And just like in the hydraulic system, the actuator does some kind of work for us. Flow controls the speed. As the difference is, we don't have to bleed it back into some kind of reservoir. We just blow it back into the atmosphere. Flow controls the speed of all actuators. Not the pressure, the flow. Okay, some review questions. I'll just let you answer these, read them and answer them. And I'm not going to talk over these review questions.